Okay, welcome again. We are going to see merge sort, its example, its algorithm, and then its program. Okay. So what is a merge sort? Again, it is based on divide and conquer strategy that we have already seen. But let's see how does it work. So this is an example. Let's say there are these elements 38, 27, 43, 3, 9, 82, and 10. So what we are going to do in merge sort, we are going to divide this list into two parts. Why we are doing this? Because this is a divide and conquer strategy. And in that, how do we solve a problem? We solve a problem by dividing a huge problem into a smaller problem and then find its solution, and after finding the solution we'll combine the problem again and we'll combine the solution actually and find out our result. So that is what we are going to do. So we are going to divide the list into two equal halves and in such a way that it will get divided because merge procedure we can apply on two sorted list, but these two are not sorted, so we will keep on dividing it. So again, if it is in equal halves, but there are 7 elements only, so 4 goes this side and 3 goes on that side. Then the this sublist have this left sublist have 4 elements, and in out of 4, again it will get divided into two halves, 2 on the left side and 2 on the right side, and this 3 for what about these 3, 2 on the left side and 1 on the right side. We'll keep on doing this until we have a single element in our list. So this is a separate single list, this is a separate single list, this is a separate single list, and this one is also, and so on. Now what will happen in this case? What will happen in this case? Okay, so this is a single list and this one is a single list. We already know that single element is always sorted, and merge procedure can be applied on two sorted lists. This whole list of one element, there is only one element in this list, and there is only one element in that list also, second list also. Now this list is sorted because there is only one element. This list is also sorted because there is only one element. Now we can apply merge procedure on these two sorted lists. We can apply merge procedure on these two sorted lists. And after applying merge procedure, we can see elements are sorted in this sublist of 2 elements. So these two are sorted now. Again, for these two, again we will apply merge procedure. So these 2 elements will also be sorted. And once these two sublists are sorted, we can apply merge procedure on these two list of length 2, and then we'll merge it into a list of length 4, and same thing will happen on this side. And after we have 4 elements, list of 4 elements that are already sorted, 3, 27, 38 and 43 already sorted, and we'll merge with this sublist that is also already sorted, and after that we can have our result. Okay, this is the first step. This first step is very important to divide it. So I have a one more example related to it. So this is our example. These are the elements. List will get divided into two equal halves because there are even number of elements, and it will keep on dividing until we have a single element, and then we will apply the reverse order. That is, we will merge this and put it in back here, and I will apply merge procedure on these two sublists of length 2 and then put it back here in the same array, and then from these two sorted lists we'll put it back to our original array. So this is the merge sort procedure. We'll see its algorithm now. So as we have seen from the example, this is divide and conquer technique. Divide and conquer is a top-down technique for designing algorithm that consists of dividing the problem into smaller sub-problems, hoping that solution of sub-problems are easier to find than composing the partial solutions into the solution of original problem. Okay, this is divide and conquer strategy. Okay, we can see a little more about divide and conquer, breaking the problem into several sub-problems that are similar to the original problem but smaller in size. Solve the sub problem recursively and then combine the solution to these sub problems to create a solution to the original problem. Okay, divide binary search is an example of the same. So this is the algorithm for merge sort, sorry, the merge procedure actually, that is the heart of merge procedure. We'll calculate the length of left sub array, then we will calculate the length of right sub array, and then we'll create two sub arrays, left sub array and right sub array. And in left sub array, I'll copy all the elements from starting to the middle, from starting to the length of left sub array, and copy the elements of right copy the elements into the right sub array from the original array, from the middle to the last element. Then we can add infinity to the last, or there are other approaches. We'll see the other approach also. And then we'll compare if left of left element at the left array is less than the element at right sub array. If it is lesser, we'll copy this one into the original array, and we'll keep on doing this until our array is sorted. So this is the merge procedure, but this is on the single sublist. And if we want to do it recursively, so this is the main algorithm where we will call the merge procedure. So merge procedure will divide this list from starting to middle, and then from middle plus one to ending. And then we will apply merge procedure on all the sublists, Okay, that's the algorithm. Now we will see its program. We have seen the example. We have seen the algorithm. Now we will see its program. So this is the program for merge sort. Let's see how it works. So we'll go to the main function first, and there we can see we have declared our array that is of this size, and we have calculated its size. After calculating its size, I have called the print array function to print the array, uh, to print the given array or before sorting. And then we have called the merge sort. So merge sort is the main sorting technique here. And there we have passed our array, this one, and we have passed the starting index, that is 0, starting index, that is 0. Then we have passed the size of array, this one, size of array. How many elements are there? There are 1, 2, 3, 4, 5, and 6 elements. 6 elements are there, so 5 will be passed here from 0 to 5. So from because we are starting from 0, so we have subtracted 1 from it. Once the merge sort will get called here, and we'll go back to where merge sort is written. So merge sort. Okay, we have written merge sort here. It is very easy one here. Okay, we'll check. We have used the array here, and then the starting point. You can take it any variable. You can write here P or R or anything. I'll write P here because it was P in the algorithm, and R is the ending point. And we have checked if P is less than R, and if P is less than R, then we need to find out the middle. You can do like this, but in order to avoid overflow, we have done this. L plus starting plus ending minus starting is the middle point. Okay, you can also do like this. That is the same thing. This one is the same thing. Starting plus ending divided by 2 is the middle point. Okay, then after calculating the middle point, because in merge sort list is always getting divided into two equal halves. So after getting divided, what we'll do, we'll call this merge sort, the same function again for different starting and ending points. So starting is same. We are starting from L, but to the middle point. So this is how we are dividing our list. This is how we are dividing our list. So for we will apply sort for first half and second half. Second half is middle plus 1 to ending point. So this will keep on calling itself. This function will keep on calling itself until there is only one element left in this sublist and this sublist. Then the merge procedure will work, that will combine these two lists, and then the previous recursive calls will get called here. So this will divide the list automatically. Okay, this is for dividing the list. So two equal halves will get divided, and it will keep on dividing the list until we have only one element left. And once we are left with one element, we'll get out of this recursion, because we have written there here one condition that starting should not be less than ending. Once starting is equals to ending, there will be only one element, then merge procedure will be called. So merge procedure will be called on two single elements, two list of single elements. Okay, then it will go back recursively, and then recursion will get stopped eventually. We'll see how merge procedure will work. So in merge procedure, what we have done, we can see merge procedure is being called in merge sort algorithm. So merge procedure here we have called. We have passed our whole array, then starting point, then middle point, and then the ending point. So for each recursive call, these pointers will be called, and we'll know what is our sublist. So let's say it is dividing into two equal halves of size 4 and 4. So what will happen here? Whole array is passed, starting is passed, middle is passed, and then ending is passed. Now we'll declare some variables. Then we will calculate the length of the left subarray, that is middle minus starting plus 1, that is up to the middle element. Okay, then length of right subarray, that is from ending minus middle. So we have calculated the length of left subarray, that is n1, and right subarray, that is n2. Now we will create two temporary arrays, left subarray and right subarray. This is how we create the arrays, declare the arrays. So this is of size 20. In this compiler, we cannot take here n1 and n2 here, because this is not allowed. That's why I've taken 2020 in turbo compiler, but in GCC it will work. You can write here n1 and you can write here n2. Now what will happen? We have copied the element to the left subarray one by one to the length of n1. So all the elements, whatever will be the length, it will be 4, it will be 2, it will be 1. The element will get copied in the left subarray. Then if it the elements will get similarly, elements will get copied in the right subarray from middle plus 1 to j. And here it is from starting to n1. Starting to n1, the elements will get copied in the L. Okay, then I have taken three variables I, j, and k. That is initial index of left subarray. Then j is the initial index of right subarray. Then k is the initial index of merged subarray. Okay, what we have done, we have taken this variable. I will start from the left subarray and it will run till n1. That is the length. And j, it should be less than this length. I is the index of left subarray. So it should be less than n1, and j should also be less than n2 because it is the index of right subarray. And we'll compare if left element at left is less than or equals to right of j, then it will get copied at k, that is at starting position. L is the starting position, and we will increment I by 1. If left is not greater, right is greater, then right will get copied and index of right subarray will get incremented. Okay, and we will increment, after that we will increment k. And once we are done incrementing, once we have finished with the copying all the elements in a sorted subarray, then if any of the elements left in left subarray, because we have not taken infinity, practical infinity is not possible. So if we have not taken infinity, then we have to do this step. That is, if I is still less than length, this means elements are not finished in left subarray, then we'll copy all the elements of left subarray in A of k, and will increment I by 1 and k by 1. And this will keep on doing until our left subarray is finished. And this is a possibility that left subarray is not finished and all the elements of right subarray are copied. Then this step will work. And this is also possible that all the elements of left subarray are copied in original array, but the elements of right subarray are not copied. Then we will go for this step. J is still less than n2. Then we'll copy all the elements of right subarray in this and we'll keep on incrementing J and K until we are finished with this right subarray. So this is our merge sort algorithm. And then we have a print function for printing the array. That is nothing but just printing our array. Let's see if it works or not. I'm going to compile it and check if there is any error. So there is no, oh, there is one error. Okay. Undefined symbol. L. Oh, we have changed it to P. We'll have to change it everywhere. So let's not change it. I hope you understood. So let's not change it and save this one. I'm going to save this one. Hold on. So it is saved. Let me save it again. And now let's run it again. There is no error. Now let's run this one. Now let's run this one. And I'm going to run this. Okay, now we can see the given array is this and hold on. Again, let's see our output. That is here. I'm going to run this one and there's one error. Okay, let's see that. What's the error? Oh, this one. Okay. I've removed this one. Now let's run it again. And let's run it again. And we have our output here. We can see I've run it multiple times and our elements are sorted in reverse order. No, it's not sorted. Let me check. There is some problem with that. Hold on.